Hello, today we are going to cover 8.2, the Pythagorean theorem and its converse. The first thing we are going to look at is the new vocab. This is Pythagorean triple, 3 whole numbers that work in the Pythagorean theorem. Now, our first theorem is the Pythagorean theorem, and you're probably thinking we've covered this so many times, why are we going through it again? It's just good review, so here we go. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Now that sounds pretty crazy, but it's already what you know. A squared plus b squared equals c squared, where c is the hypotenuse. And the hypotenuse is the one that's across from the 90, if you haven't picked up on that yet. Okay, so find the missing measures using the Pythagorean theorem. Notice we are finding the hypotenuse, so we have a squared plus b squared equals c squared. In this case, it's x. So we have 16 plus 49 equals x squared. So we take the square root of this. Actually, I should probably add first, huh? 16 plus 49 is equal to 65. And now we take the square root of that. And yes, we can go ahead and find this as a decimal, which is about 8.06, or we can go ahead and see if there are any numbers that we can pull out. Turns out there is no groups of primes that we can pull out, so this is either the most simple as you can get, or you can write it as a decimal. So those are our x values. You can't reduce the radical in any way. Alright, find the value of x. Once again, notice this time we have a leg, so we have 8 squared plus x squared equals 12 squared. These should be pretty simple for us, as long as we don't mess up the arithmetic. (144 minus 64 is 80. Oops, we're not ready for that yet. Take the square root of both sides. We end up getting that x is equal to the square root of 80. And the square root of 80 as a decimal is about 8.94. Now, some of these problems are going to ask you to simplify the radical, not write it as a decimal, so here we go. We are trying to find, there's 2 ways we can do it. The biggest square root that goes into this number, or you can do factor trees. Notice how I just factor it. 2 and 40 multiply to 80. 2 is a prime, so we're done there. 40 is 2 times 20. 2 is a prime. 20 is 2 times 10. 2 is a prime, and then 10 is 2 and 5. We are down to only primes. Because this is a square root, we are looking for groups of 2's, or groups of 2 numbers, not just specifically the number 2, but groups that have 2 numbers, so there's 2 of them. So we have 2 times 2, root 5. So this is 4 root 5. Now 4 root 5 is actually equivalent to 8.94. These are both the same. It just depends on how it asks for the answer to be written to which one you need to write. Okay? If we are finding x here, we are finding the hypotenuse once again, so we have 5 squared plus 8 squared equals x squared. So 25 plus 64 equals x squared. This would be 89. And because they gave us multiple choice, we know that that is C. Alright, and one more. Notice that we do have to do the simplification of our radical here. So we have 6 squared plus x squared equals 12 squared. That's like the hardest part of this, is the new thing. Did we just do this one? No, not quite. So we have x squared equals 108. Now, there's a couple ways you can go about that. The factor tree I like a lot. You can also figure out the biggest perfect squares, biggest singular perfect square that this goes into. So we can make a chart of perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and so on and so forth. Okay? Now here's the deal. You can take this number divided by any of these. Notice I would start smaller than that, obviously, because you are looking for something that comes out even. So I take 108. I'll divide that by, say, 81. That gives me a decimal. I know that one doesn't work. I take 108. I divide that by 64. Gives me a decimal. Doesn't work. 108 divided by 49. Once again, a decimal. Try again. 108 divided by 36. Gives me a whole number. So I know 36 times 3 is equal to 108. I also know that the square root of 36 is a perfect square. So 6 root 3 is my solution. If I wanted to, I could have done the factor tree. I would have gotten the same thing. Okay? That is our solution. So now we have our Pythagorean triple idea. Common Pythagorean triples, these are just ones that have 3 whole number side lengths. So we have 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. You might have noticed these before. And then notice underneath these, we have a times 2 row, a times 3 row, and then so on and so forth, okay? So this is just a times question mark. As long as it stays 3, 4, 5, you're good to go. You could have any combination. Say you plug in 8 for x. That would also be a Pythagorean triple. 3 times 8, 4 times 8, 5 times 8. Same thing works for all of these too. As long as they're multiples of the common Pythagorean triples, you're good to go. Okay? So we're going to use those Pythagorean triples. It's almost easier just to go ahead and solve them than to memorize the Pythagorean triples. But we can scroll up. So we're looking for a 26 and a 24, where the 26 is the longest side. So I see that right here, because we know the hypotenuse has to be the longest. So 10, 24, and 26. So we know x equals 10 by the Pythagorean triple chart. Or you could have solved. Either way, totally fine. Okay? Now we have a real-world problem. A 20-foot ladder is placed against a building to reach a window that is 16 feet above the ground. They have a nice picture for us. If there's not a picture, I would suggest a drawing. How many feet away from the building is the bottom of the ladder? So right here, we just simply have a triangle. We have a 90 degree. 20 is our hypotenuse. Oops. 16 is a side length. X is what we need to find. So let's see, is this a Pythagorean triple? Do we have 20 as a hypotenuse? I am not seeing it right away, so it's just easier for me to solve, okay? If you saw one right away, go for it. I don't want to get weighed down too much by just using the chart, and I know how to actually solve the Pythagorean theorem, so I might as well just use that information.
Connor Wagner, please report to the main office. Your ride is here. Connor Wagner, please report to the main office. Your ride is here.
Alright, so we end up getting something super simple. Turns out it was a Pythagorean triple. So we'll have to go look at that. And this length from the base of the ladder to the wall is 12 feet right here. So let's scroll back up, look at the Pythagorean triples. So it looks like it is actually this one where you multiply each of the triple by 4 to get 12, 16, and 20, just like it is down here. Yep. Alright. So once again, we have our picture here that we should draw. A 10-foot ladder is placed against a building. The ladder is 10 feet. The base of the ladder is 6 feet away. How high does the ladder reach on the building? Alright. Maybe it's a Pythagorean triple. Actually, based on the answers it gives us, I think it is. So let's go see. Can we pick one out right away? A 10 and a 6. That means our final length would have to be 8 because the hypotenuse is 10. A leg length is 6, so the other leg length must be 8. If you don't believe me, try it out. And it does turn out to be 8 feet. Alright, so we have the converse of the Pythagorean theorem now. If the sum of the squares of the length of the shortest side of a triangle is equal to the square of the length of the longest side, then the triangle is a right triangle. So basically it's saying if this is actually true, then it is a right triangle. If it's not true, then it's not a right triangle. And in that case, if the square of the length of the longest side of the triangle is less than the sum of the squares of the lengths of the other sides, then the triangle is acute. So if the hypotenuse measure is smaller than the side lengths, then it's an acute triangle. And if the hypotenuse length, when it is squared, you're still doing Pythagorean theorem, you're just looking for inequality now, then it is an obtuse triangle. So if the hypotenuse is greater than, obtuse, less than, acute, equal to, right. So determine whether these can be the measures of the sides of a triangle, first of all, and if so, classify the triangle as acute, right, or obtuse. If you recall, the side lengths of the two shorter sides must be greater than the longest side, and this is perfect, so that checks out. It must be greater than, not greater than, or equal to. So it is a triangle. Now we need to check if it is acute, right, or obtuse. So we set up the Pythagorean theorem. I guess I should put a box here because we're trying to fill in that. What is it? So we have 81 plus 144 plus, something, 225. So 144 plus 81, is 225. So because these are equal to each other, this is a right triangle. And what would we call this? Based on the converse of the Pythagorean theorem, just like that. Okay, let's try another one. Determine whether these can be the measures of the sides of the triangle. If so, classify it as acute, right, or obtuse, and justify. Okay, so first of all, check to see if this can even be a triangle. Is these greater than 13? Quite obviously they are. So it is definitely a triangle. Now the question is, what kind? So the biggest number has to be the hypotenuse number. So we have 100 plus 121 is something 169. So we have 221. That is greater than 169. So because the hypotenuse number is less than 221, this is an acute triangle because of the, let's look up here, Pythagorean inequality theorem. So when the hypotenuse is less than the two side lengths, it is acute. Bet you guys didn't know you could do this much with the Pythagorean theorem, huh? It's pretty cool, everything you can do with it. And lastly, determine if these can be the measures of a triangle. If so, classify it. So we need to check 7 plus 8 has to be greater than 14. That does check out. 15 is greater than 14. So now we need to decide if it's acute, right, or obtuse. So 7 squared plus 8 squared is something to 14 squared. We have to figure that out. Notice, I know that this has to be the one by itself because it is the biggest side. The hypotenuse is always the biggest. If, of course, it is a right triangle, okay? So 14 times 14 is 196. Go ahead and add 49 plus 64. We get 113. That is less than 196. So because the hypotenuse side, the bigger side, is greater than the other two sides added together, we know that yes, this is a triangle. It is obtuse. And then it looks like we have one more. Determine whether the set of numbers 14, 18, and 33 can be the measures of the sides of a triangle, and if so, classify. So 14 plus 18 is greater than 33. (14 plus 18 is actually not greater than 33. So this is not even a triangle. The two side lengths would not ever connect. They would be just close, but not quite touching. So it doesn't even form a triangle. And then this last slide, it is not your actual homework, so you can go ahead and cross that out. Alrighty, have a great day.